Good afternoon. I'm Eric Cooper, the Director of Cloud Systems Engineering at Intel, and I'm going to talk about making OCP real. But before we get started, I wanted to thank you for attending during lunch. Mary Kay is walking through the area with a bowl, and you can throw your business card in there, and at the end we'll have a raffle for an Intel NUC mini PC and these mugs, just as a sign of thanks and trying to make sure we keep your attention here. So a couple things I'm going to talk about. We're here in the expo hall, and it gives us an opportunity to look at all the different products that are available to the OCP community, the real products that are available. And what we've seen over the past several years is the collaboration between end users and OEMs. In my role, I work closely with end users who are developing the infrastructure that they run their cloud services on, and I also work with the OEMs that develop the products for that infrastructure. And it's nice to see as you walk among all the booths that the OEMs have the real products there, the fruits of their hard work over the past 4 years. So I'd encourage you to go visit those and see what's available to the OCP community. Now what I'm going to do is talk for a few minutes about the current status, where we are, and then I'll talk for a few minutes about where we're going next. And to do that, first I want to think through what problems end users are trying to solve. Whether you're a large public cloud service provider, or you're a small public cloud service provider, or an enterprise looking to adopt private cloud, you're thinking in terms of how do you maximize what you get out of your infrastructure. And so we know the service providers today are driving dramatic hardware and software innovation that's creating new services, better services, and they're doing it in a way that's driving better and better performance per dollar. And we also know from talking to other service providers and the enterprises that they see these best practices and say, I want those. I want a path to be able to adopt those best practices. And so as we work with the OEMs and as we work with the end users to define these capabilities, what we're really trying to do is build out a broad portfolio of products that deliver the capabilities that the infrastructure needs to run cloud. And so what we've done here is broken out into a couple of buckets: the servers and storage and management and networking, the types of products that are available to the community now. And you can see over the past 3 years that there's been more than 10 server and storage boards developed that have specifications released and that have been developed by the OEMs and the OCP community to be ready to deploy. And I have a couple examples up here that I'll show. This one right here is what the OCS, Microsoft's rack specification, implements for their compute node. It's a 2-socket Xeon E5 V3 product that is now in deployment in data centers in the Northwest. The more general purpose version of this board is what's called the Decathlete 2.0 specification, and this is another 2-socket implementation of a E5 V3 CPU as well. But the products you can see have evolved over the past 3 years to include the Decathlete going from 1.0 to 2.0 as the CPU generations have changed. Some of the boards at Facebook have been developed on a half-width board, a narrower board that's been progressing over the past several years and is available through Quanta and WeWin and others manufacturers. And then we're also working on some microserver products that are single-socket nodes that deliver new capabilities. And one of the ones was highlighted in Jason Waxman's keynote earlier today, which is a microserver based on the Intel Xeon D SoC. So it's 4 and 8 core Xeon 4 and 8 Xeon cores in an SoC on a single socket module. And in the Open Compute rack, you can either have a 2-socket tray or a multi-node tray of these in the same infrastructure. When we move into the storage space, Facebook and Intel have been working closely together for several years in some designs that have been delivered into the OCP. This is a head node for one of the storage modules called Panther Plus. It's based on the Intel 2000, the Avaton, codename Avaton, and it delivers the head node for storage, but it also can be used as a compute node in some implementations. So we're seeing a lot of different innovation in this space as the OEMs work with the end users to develop these boards. The other space we see a lot of innovation is in the networking line here. And what we've worked with Facebook on is a combination of these OCP mezzanine cards. And so that we've seen pretty broad adoption within the end user community of both the 10 gig version and then what we're going to be releasing with the community this year, the 40 gig version. And so we're seeing that along with bare metal switch specifications come out that enable more products to be adopted in this community. And then finally, the management space has continued to be an important area of innovation. And back in 2013, the management work group created the server management specification. And now as we move forward into 2014 and beyond, we've created, with the partnership among many of the different OCP partners, the switch abstraction interface, as well as one of the things that Microsoft has contributed to the OCP community, a chassis manager, and some hardware that can run their chassis management infrastructure. So you put all this together and you see this growing portfolio of products that are real and available today. And so part of our challenges are now lie in how do we drive adoption and facilitate the adoption so that we can speed and make it easier for more end users to deploy these technologies. Now, many of you know Rackspace has been involved with OCP for years. They've been one of the active participants in it, and Intel's been collaborating with them, not just to develop their products and technologies, the ones that they need to run their business, but also to help lead the OCP community. And I'd like to invite Aaron Sullivan up. He's a distinguished engineer that many of you know at Rackspace, and he's going to talk about how Intel and Rackspace have been collaborating and some of the aspirations for the future.
Hi, everyone. We got a click.
I'm sorry, yeah.
Yeah, all right, let's see.
Hit the green button.
Hit that button. There we go. Okay, our journey with Open Compute started well before we shipped our first server platform and our first applications. We were involved with Facebook and many of the other founding members of Open Compute to see many of the boards and racks that you saw Eric present that were on the right-hand side of the screen. In their early phases, the equipment as designed, both mechanically and in terms of motherboard and feature set, didn't meet all of our requirements, but we saw potential to be able to take those devices and make some small modifications to them and be able to put them not just in our data center for our applications, but to be able to create a platform that could be easily commercialized and work in any enterprise data center. So we built it to support diverse power, AC power if that's what you need into the rack, hot swap fans, hot swap hard drives, a little bit higher density and better cable management. And we worked with Intel as a critical partner in that on the network side of things with some special systems management capabilities that we needed that were a little better integrated for our purposes than what were delivered in the original spec. And we also worked with Intel on some flash media that we integrated into the machines. We were able to take the motherboards that we were shipping for our cloud servers platforms and some other applications, and doing a little extra optimization, we could squeeze extra performance out of the system because we could touch parts of the firmware stack and make some changes to the way that the system was designed in firmware in general to get extra performance out of the system. We also created this rack with Quanta. We collaborated to create this. We call this Yellowfin. And we ship these, we run our enterprise data warehouse at Rackspace on this platform using this precise equipment layout that you see here. And we were surprised last year in September to see at VMworld that VMware had selected this same design, which I think Quanta calls the Rackgo X700. We saw it used as a reference platform for VMware's Evo Rack storage platform. And we didn't even know about it until after they picked it. But I think an open source community really picks up a lot of steam. It's a sign of a lot of steam when end users and consumers just start freely selecting from what's out there and going and building their own solutions and taking them to market. And Intel was a very key partner in helping us get this whole thing refined to the point that it will run in any enterprise data center safely. Finally, we did some additional development last year on a new product that was uniquely OpenStack and Open Compute that we call OnMetal. We'll talk a little bit about that tomorrow. As we started to build OnMetal, it was a bare metal cloud, no hypervisors. And if you want to ship the kind of security capabilities and the kind of speedy provisioning capabilities that you get in a normal, sort of typical cloud with hypervisors into an environment that's just bare metal, machines provision that fast, you have to do work at the firmware level in a system to provide the security for your end users, security for not just the owner of that system, but the other people around them, and the long-term sustainability of the server. So there was extra work we had to do there. And I don't think we could have shipped that service if we had not been collaborating with Intel as a partner, with Quanta as a partner in the Open Compute community and the OpenStack community. I think it's proof that you can create a high-value, vertically integrated stack and do it in the open. And you can create something new that people want that's very differentiated and do it in the open, and you get a lot of value for you and your customers. In the future, we'd like to move towards more openness at the firmware layer in the server. So we are collaborating with Intel and talking about how we enable more openness in the BIOS, more openness in the BMC, maybe specifications that ship not just mechanical and electrical, but here's the open source firmware stack that goes with this. So you can package the whole thing top to bottom, and people can do the same kind of custom development that we did with OnMetal in their own applications. Thank you.
Okay, hey, thanks, Aaron. So let's look a little bit at where we're headed and the types of things that the OCP community needs to go work on next. And we know we'll see a continued explosion of mobile applications and enterprise applications that just drive immense demands on the cloud platforms. And so we're going to need to be able to address that. We also hear from our partners, the service providers, that there's tremendous benefit if we can help them decouple the process of developing applications and services from the work to develop and deploy innovative and new infrastructure. And by decoupling these work streams, we can unleash the innovation on the pace they naturally follow without coupling them together. And so the cloud platform in the future needs to be able to address those needs, but it also has some other capabilities as part of delivering that. And as an example, one of the things that we know the platforms of the future are going to need to be able to do is scale capacity easily, whether it's compute, storage, or networking, depending on how your workloads unfold and how your services unfold across your full set of infrastructure. You need to be able to scale those independently. We know that the workloads are going to continue to change, and it's impossible to predict what the workloads will need. So the infrastructure needs to be able to flexibly adapt to those changing workload requirements. And then also the workload, or the infrastructure needs to be able to be intelligently managed and orchestrated so that through real-time data and analytics and telemetry, we can make sure that we provide the intelligence and the controls so that the end users can optimize their capital utilization as well as to deliver better and better operational efficiencies. And so this is where Intel's Rack-Scale Architecture program comes in. We're working with the industry to define a logical architecture that encompasses compute, storage, networking, and management, and then delivers the ability to pool these resources, disaggregate the resources before they're able to be composed dynamically to deliver the compute, storage, and networking resources that are needed for the specific workload demands. And wrapped around all of that, we're working with the industry on simplified management framework that covers not just compute, like IPMI and some of the previous standards have covered, but now compute, storage, and networking in a unified framework. And so together, as we define this logical architecture, we're going to be working on developing the components and technologies, the CPUs, the SSDs, the interconnect, the networking equipment to deliver the capabilities that our OEMs need in their products, that they can innovate around, that ultimately the end users deploy. And we're also working with industry standards bodies like OCP and DMTF and the Project Scorpio over in China to make sure that there are implementations that are defined that can deliver these capabilities to the end users. And so as we look at the progress we've made over the past couple of years, the past 3 or so OCP summits, we've delivered progressing levels of capability. And now in our booth, we're able to show this software framework working, some of the network technologies we're delivering. And you'll see as you talk to some of the different OEM partners who have announced, for example, Quanta, Dell, HP, Huawei, Inspur have all announced publicly their alignment with us on this. So has Ericsson, and some have even announced some of the product plans, and we'll see products evolving and being delivered over the next few months and years. And so as you visit the booths, hopefully you'll see some signs of these capabilities and this infrastructure of the future be shown in some of our partners. The last thing I want to leave you with is sort of where do we go from here. So when we think about what we've accomplished over the last 4 years in OCP, we've delivered a broad portfolio of products. Those products are ready to be deployed. You can improve your CapEx, you can improve your OpEx by working with the ecosystem to go deploy those products. We also have seen a tremendous amount of innovation, and we want to continue to use the OCP framework, the OCP community, to drive that innovation cycle. And as we think forward, that innovation will manifest itself in what we call the Intel Rackscale architecture that delivers dramatic improvements in capital efficiencies, dramatic improvements in the capacity per IT dollar, and ultimately creates a much easier path for our partners, end users, and OEMs alike to adopt cloud technologies. So with that, I'm going to go ahead and shuffle around here in the bowl and figure out who won our Intel NUC. Oh, we got another entry? It's not too late. You got to come up though. Any more entries? We're closing in 5, 4, 3, 2, 1. That's it. All right. So for the Intel NUC, Peter Oyang from Quanta Computer. Come on up. If you're not here, we're going to the next guy. Peter's not here. Pale Bustarde. He's here, and he's won the Intel NUC.